Hello everybody. We're going to continue looking at the 2001 Fermat paper. We're up to question number 16, so that's what we're going to be taking a look in this video. As always, click the link in the description to get a copy of this contest for yourself. Okay, so what does question 16 say? Let's have a look. Or I guess what does it ask? In the triangle ABC, the one we have shown here, AX is equal to AD, so there's a smaller isosceles triangle. And CY is equal to CD. So we have yet another different isosceles triangle here. The measure of angle XDY is, okay. Well, I notice immediately that I've got a right angle at B. So I can start trying to work it. Give some of these angles names and start working them all out. So suppose we give the angle at A the name, I don't know, theta is a good name. Because the sum of the interior angles of a triangle is 180 degrees, and 90 degrees are already spoken for at B, the angle at C will be 90 minus theta. Maybe we can work some things out from there. Okay? So, let's draw ourselves a picture. Well, let's get another page, fresh page, and then we'll get ourselves a picture. We'll draw it nice and big so we can scuff it up with some math marks. C, B, A. We have an isosceles triangle here at D. That doesn't look isosceles. We'll draw that a little better. There, that's more believable. Okay. So I'm going to let the angle at A be theta. So as I said, the sum of the interior angles of a triangle is 180 degrees, and that means that C is 90 degrees minus theta. Okay. Now that alone doesn't help me because there's still these angles here at X, D, and D and Y. But because we have isosceles triangles, we know that angle CYD is going to be equal to angle CDY. And angle AXD is going to be the same as angle ADX. So we're going to give these guys names as well. And angle, what's the other one? CYD. We're going to call that Y. So we have angle X here, and X here, and we have Y here, and Y here. Okay. So now the angle that I want, which we will place in orange, is this one right here. So immediately I can see angle XDY is going to be 180 degrees minus X minus Y, because they form a whole line together. So if I can figure out what X and Y are, or even just what X plus Y is, I'd be all set. I suspect I probably won't be able to figure out what X and Y are, but I could probably figure out what their sum is. Okay. So we've got a lot of the angles here. We're not given any actual lengths, so we aren't probably going to be able to calculate a whole lot of stuff here. But if I take a look at these angles right here, which actually we'll put in purple. These are exterior angles to our triangles XAD and YCD, respectively. And as such, they are sort of the sum of the two other angles, not the one that they're associated to. Another way to see this is together this angle and Y form a complete 180 degree line, but the sum of the angles of the interior angles of a triangle are 180 degrees So really, this purple angle has just got to be what's left over. So it's going to be 90 minus theta, or 90 minus theta plus y. And likewise, this one here is going to be theta plus x. Okay. So I'm getting them closer. I'm getting them related to one another. But what else is there? Well, I have a quadrilateral here. And the sum of the interior angles of a quadrilateral is always 360 degrees. Imagine a square or a rectangle or any parallelogram. You're always going to get 360 degrees. Okay? So, 90 degrees, which is our angle at B, plus our angle at X, plus our angle at Y, plus the other angle at D that we need, must be equal to 360 degrees. Well, we can do some cancellation. 90, that 90 will go. We'll be left with 270 over here. This theta and this minus theta will cancel out. This 90 and 270 will become 180. And I haven't gained any new information here. I have once again realized that x plus y plus the angle that I want is equal to 180 degrees. Okay. So that hasn't worked out. Ah, okay. So I made a bit of a mistake. I jumped ahead too quickly and gave x and y names. I could work them out in terms of theta. There's my mistake. So I know that x plus theta is equal to 180 degrees. You know what? We're just going to clear off this whole page right here because I don't need it. So x plus theta is equal to 180 degrees. So 2x is 180 degrees minus theta. X is going to be 90 minus theta by 2. Similarly, y plus 90 minus theta is equal to 180 degrees. So 2y is going to be 90 plus theta. Y is going to be 45 plus theta over 2. Okay. The angle that we want, 180 degrees minus x minus y. That's 180 minus 90 minus theta by 2, minus 45 plus theta by 2. So these theta by 2's are going to cancel each other out. And we are just going to be left with 180 minus 90 minus 45, which is 45 degrees, and that's the answer that we want. And would you know it, 45 is one of our possible angles, giving us an answer of C. Okay. So that took me a little longer than it should have, but that's okay. You guys now have a nice little example of how you can very easily overlook some information and go down the wrong path and end up with an equation that was one that you already had that didn't really solve anything. That can happen when you're working out contest questions as well, and now you know it happens to everybody. So that was question number, oh geez, what was it? 16. So that's question number 16 on the 2001 Fermat paper. Join me in the next video for question number 17.